Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we're doing the June 2016 paper, and I'm updating me model solutions that I uploaded earlier in the week on the Monday after the exam was sat. But obviously I made a couple of mistakes, but not as many as I thought I did, so it wasn't too bad, and I'll be explaining some of the things that I got wrong in Monday's video. So let's get into things. Question 1. Solve the inequality 1 minus 2 brackets x minus 3 is greater than 4x. Well, what you do there first is expand the bracket. Be careful of your double negative here, because minus 2 times minus 3 turns into a plus 6. So you end up with that. Rearranging, you end up with 7 is greater than 6x. Therefore, x must be less than 7 over 6, or 7/6. So a nice easy 3 marks to start you off. Question 2 then. The gradient function of a curve is given by dy dx equals 3x squared minus 4x plus 2. Find the equation of the curve given that it passes through the point 1, 3. So the first thing we have to do to get back to y is integrate the gradient function with respect to x. So we add 1 to the power, divide by the new power, but don't forget your c plus c, and we've been given some information in the question. So where we see a y, we can put a 3. Where we see an x, we can put a 1. So we do that. Rearranging, we can see a c is a 2, and then rewriting it in y equals form for the examiner, you end up with that. Question 3 then. Find all the values of x in the range 0 to 360 that satisfy 3 sin x equals 4 cos x. Well, bad news here, because there's 2 pieces of trig, so I cannot solve the equation. So what I'm going to do is divide both sides by cos x. So I get that. And I know that cos x over a cos x will cancel out and just become a 1. And a sin x over a cos x will cancel out and become a tan. So we've got 3 tan x equals 4. Divide both sides by 3 and you get tan x equals 4/3. And just to finish it off, we'll get a calculator involved, do the shift tan of 4/3, and you'll get one answer of 53.1. But then remember, you have to add on 180 to get your 233.1 as well. And we only want solutions in between 0 and 360. Question 4 then. You were given that f of x equals x cubed minus x squared plus x minus 6. Show that x minus 2 is a factor of f of x. Well, all we do here is shove a 2 through. Obviously we reverse park whatever's in this, so we see a minus 2 in there, so we put a plus 2 through the function, and that should equal 0. It does, therefore it's a factor, and you've grabbed yourself a mark. The equation, we're showing that the equation f of x equals 0 has only one real root. Well, first of all, you have to divide your x minus 2 into the cubic to get that. So we should get a quadratic of x squared plus x plus 3 when we do a little bus shelter, and we'll say x minus 2 there, and we've got a cubic there, and then we'll say, what do I times this x by to get this here, which will be that x cubed, by the way. And then we'll say x squared, we'll put on top, times throughout, subtract, and you'll end up with 0 at the bottom somewhere down here, and you'll know you've done it right, and you'll get that on the top. And that cannot be solved, because if we do a quick b squared minus 4ac, because remember on the quadratic equation you have a root here, and that is b squared minus 4ac, and we know that if b squared minus 4ac is less than 0, then you cannot root a negative number, therefore it can't be solved. Therefore there's only one real root, which is 2. So if you do a quick b squared minus 4ac, so it'll be, hold on, let's have a look, so it'll be 1 minus 4 times 1 times 3, which is 1 minus 12, which is minus 11. Therefore b squared minus 4ac is less than 0, therefore it can't be solved. One real root, which is x minus 2. So hopefully that makes it a bit more clear. Obviously in an exam it depends how the examiner interprets it, what's in the mark scheme and stuff, but that is the reason why it can't be solved. Question 5 then. John draws a triangle ABC with sides AB equals 12, BC equals 16 and AC equals 20. However, he can only measure the sides to the nearest centimetre. State the smallest possible length of AB in John's drawn. So the smallest possible length is 11.5 because that is the smallest number that will round up to 12. And this second bit caused a lot of controversy in my first video because I panicked a bit when I was recording because I hadn't labelled my triangle. But the thing we want, calculate the largest possible angle of B in John's drawn. So to make the largest angle possible, I need the smallest possible sides connecting to the longest possible side. So I drew myself a triangle like that, and in the video I called this here A, but that is actually B. We're going to call that A. I'm going to call that C. Now, the shortest possible lengths of BC and AB are obviously 11.5 and 15.5 from the question. And the longest possible length of AC will be 20.5. And then if I call the angle up here X, then I can do the cosine rule and get that and get that and get that. So my X value is 97.7 degrees, and that is apparently the correct answer. That's what I'd interpret to be the correct answer. So yeah. Question 6 then. Two cars are initially at rest facing in the same direction on a straight road. Car A is 100 metres ahead of car B. The two cars start from rest at the same moment. Car A travels with a constant acceleration of 1.5 and car B moves with a constant acceleration of 2. So find the distance that car B travels before it overtakes car B. Another one that caused a lot of discussion on the original video. Just list your variables to start off with, and then just go with what you know. Suvet. So S equals ut plus a half at squared. Put in your numbers for A, so it's 0.75 t squared. For B, it's S equals t squared, but A starts 100 metres ahead of B, so it'll be S plus 100 equals t squared, therefore S equals t squared minus 100. So there are your equations of motion for A and B. We want the distance though, so when they're overtaken they're going to be at the same point, so we set the distance functions equal to each other, and we get that, which is that, which is that, which is that. So 20 seconds is the time. And then what I did in my original video is I pasted it back into the B function, the A function, which is this one. Now I've still done that, but remember B has to travel 100 more meters than A, therefore I'm just going to add 100, and therefore it's 400 meters. So there you go. V equals U plus AT for the speed, because that's the second part, the speed of B at the moment when it overtakes car A. So V equals 0 plus 40, therefore V is a 40. Question 7 then. An extension to the roof of a house is shown below in the diagram. The ridge CD and the lines AB and PQ are horizontal. PQ is perpendicular to CD. M is the midpoint of AB, and the line PM is vertical. APB is an isosceles triangle with height 2 meters and base length 3. Angle PQM is 45. Now, there is easier ways to do this question, but you know, I just went with the trig because when I first looked at this, I couldn't really get my head around the diagram, so I just had to pencil in what I knew, and that's what I've got. So the length PQ then. PQ is perpendicular to CD, so if we look at that there, the important thing is there that is a right angle, and therefore QPM is a right angle triangle, because this is a right angle as well. So I'm doing the wrong one at the minute. PQM, that is this one here. There you go, because remember PM is vertical, so we're only looking at this triangle. I am just going to erase that red line for the moment. So this is the triangle that we're focusing on, and the length of that PM is 2, and we've got x, and we've got an angle of 45 degrees there. So PQ is 2 tan 45, therefore PQ is 2. And that's for 1 mark. Part 2 then, the angle PBQ. So that is this angle here. I am just going to get rid of the pen marks again because it could get quite messy, this. Like that and like that. So we want that angle there. We've got that length here of 2.5. We also now know this angle here, which is a 2, and we want to know, well, we don't want to know this side, but this is the triangle that we're focusing on, and we've got this angle to work out here. So it's going to be through Pythagoras, by the way. That's why I got the 2.5, because it's 2 down to PM and 1.5 there. So if we square them up and add them together and root them, we'll get PB, which is 2.5. And to work out the angle, we do the shift tan of the opposite over adjacent, which is 2 over 2.5, which is 38.66 degrees. There's probably easier ways of doing it, but that's the way I did it. I let the trig lead us and did it like that. Question 8 then, another question which caused us trouble. Shaky question for me, but I think I know what's going on now. Write down the binomial expansion of 1 plus delta to the 3. So we go binomial. We've got with C numbers here, 3C0 all the way up to 3C3. And we're timesing that by the person on the left starts high and then dies. The person on the right starts low and then grows in terms of powers. And this should be 3 there. And apart from that, that is perfect. So if you just write it, this in ascending powers of delta, then you'll have got the 2 marks. Hence explain why if delta is small, then 1 plus delta to the 3 equals 1 plus 3 delta. Well, what I was trying to get across with my explanation here is that if n is very, very small, so if it's less than 1, when you power it, it gets smaller and smaller and smaller. So, for example, I think there was a maths teacher in the comments, he said if you let delta equal 0.5 and you squared that up, it would be 0.25, and then if you cubed it, it would get smaller and smaller and smaller. And basically, if it's very, very, very small, so like 0.05 or something, you'd square that up and it would be very, very small. And as the power tends to infinity, it almost becomes irrelevant and you can just forget about it. So we just write the power 1 term and the power 0 term, which is 1 plus 3 delta. That's what I was trying to explain. It's pretty difficult to explain it, but that's what's going on there. Part 3, I'd done perfectly right. Substitute x equals 1 plus delta into the equation. So we'll substitute that in for an x here, and nowhere else. And we get that. But remember, it's asking for what x is, so we have to add 1 onto that answer, and that'll equal 1.05 as the answer of the root. So I just didn't read the question, to be honest with you. There you go, that's why you should read the question thoroughly, but that is turned into quite a nice question in the end there. Question 9 then, a curve has the equation y equals x cubed minus 3x squared minus 3x plus 4. Points P and Q lie on the curve, the coordinates of P are 3 minus 5. Find the equation of the tangent to the curve at P. So, we need a point, we need a gradient. We've got a point. How do we find a gradient? We differentiate, so power to the front, knock 1 off the power. Put x coordinate through, and we get dy dx to be 6, so that's the gradient of the tangent. Y minus b equals mx minus a. Put in your numbers. Expand, tidy up, job done, 4 marks in the bag. Part 2 then, the tangent of the curve at Q is parallel to the tangent to the curve at P. Find the coordinates of Q. So if I know that the gradient is 6 because it's parallel, remember parallel lines have the same gradient, we can set with gradient finder, which is this, equal to 6. So we get that. And I see common factor 3 there, so I divide throughout. Tidy up and end up with that, and that's a beautiful quadratic which factorizes to that. Great news, because that's going to be in x equals 3, and we'll see that appear up here. So we know we're doing something right, and we end up with that. The other x coordinate is -1, so that must be the x coordinate of q. Put that back through, your y's are 3, and therefore your q is -1, 3. I think I wrote them the other way around in the earlier video, but that was just a typo. All the maths was right. Question 10 then. On the axes given in the printed answer booklet, indicate the region for which the following inequalities hold. You should shade the region that is not satisfied by these inequalities. So we're given 3 inequalities, given a graph, we'll draw it on, and using the cover-up method, 4x equals 30, so x is 7.5, which is down here. 3y equals 30, y is a 10, so we'll cross out up here, join them up, and that's telling you want to be under the line, so you shade above it, so we'll do that. And then y is greater than 2x, that's the line y equals 2x, wants to be greater than, so we shade under, which is this side here. And x is greater than or equal to 1, that is just a straight line going through 1, and we want to be over the line, so we shade under it, and we get a critical region of R here. And then the next part of the question, find the maximum value of 7x plus 4y subject to these conditions. So you draw in your objective function just by letting 7x plus 4y equal a friendly number of 28, so x must be a 4, y is a 7. So we'll join it up, and then we'll go in a parallel fashion with our ruler or our arm or whatever, and we'll find that the max is at 3,6, therefore your profit is going to be 45 when you put it back through this equation here. Question 11 then. Awful question, this one, really. I think a lot of people had trouble with this one. But a railway track runs due east-west and is crossed at O by a road running due south-north, as shown below. The crossing has no barriers. That still gets us that. It's very morbid from OCR. Initially, a train is at the point B, 400 metres from O, and the car is at the point A, 100 metres from O. The train is travelling at a constant speed of 25 towards O, and the car is travelling at a constant speed of 20 towards O. At time t seconds, the train is at point Q, and the car is at point P. So that's shown on the beautiful diagram there. So, find an expression for OP and OQ as functions of t. So OP, O to P, is this line here, and remember, it starts 100 away, and as time goes on it's getting closer and closer, therefore you take off 20t. O to Q, 400 minus 25t, it starts 400 away, but as t gets bigger and bigger it's getting closer and closer, therefore it's minus 25t. So next bit, the distance between the car and the train at time t is x meters. Find a formula for x squared in terms of t. Give your formula in the form x squared equals a plus bt plus ct squared, where a, b and c are to be determined. So there we go, I just drew myself a lovely little triangle. Got my newly found equations there. Through Pythagoras, x squared must equal 100 minus 20t all squared. Add 400 minus 25t all squared, and there you go. If we expand that, we get that, believe it or not, and that is in the form a plus bt plus ct squared. Right then, differentiate this formula with respect to t and find the time at which x squared is a minimum, hence find the shortest distance between the car and the train. So dx squared dt, power to the front, knock one off the power, we end up with that. When it's a minimum, that means we can set it equal to 0, so we end up with that, which is that, and then divide both sides by 2050, so t is 480 over 41. Just leave it as that for now, and that's what I've done. Then throw that back through your x squared formula to get that, and therefore tidying that up, your x squared is that, therefore your x must be 171.8 meters as the shortest possible distance between them. I think a couple of people got confused as to why this time was bigger than the time I'm going to talk about next, but that is because it's not necessarily before the meter, or the shortest distance could be somewhere up here when the train is here and that's there. You know, you don't know, and it's not mentioned in the question, so that's why that's a slightly bigger number than the next one I'm going to show you. Part 4, show that the car passes point O before the train. So if car travels at 20 meters a second, it'll get to O in 5 seconds, because 20 meters in a second, got 100 to do overall, so it's going to take him 5 seconds. Similarly for the train, if he's travelling at 25 meters a second and he's got 400 meters to travel, he's going to reach there in 16 seconds. So that's where those numbers come from, and some people were confused as to why that's 5 and why this is somewhere above 10. I think it's about 11 is the time there, but never mind. That's well, as I was saying before, they're not necessarily before they've reached the barriers, the shortest distance. But that's that. Question 12 then. The line L1 has the equation 3x minus y equals 1, and the point P has the coordinates 8, 3. Find the equation of the line L2 which passes through P and is perpendicular to L1. So y equals 3x minus 1, just rearranged the formula at the top here. Therefore your gradient of that line is 3, and we're told it's perpendicular, so that means our new gradient is minus a third. Y minus b equals mx minus a. We've got a point, we've got a gradient. Times through it by 3 there to get rid of the fraction, and you end up with that. Tidying up, 3y plus x equals 17. Part 2, find the coordinates of the point Q where L1 and L2 intersect. So we've got that. Where we see a y here, we're going to paste in this 3x minus 1 for this y here, and we end up with that. Expanding, you end up with that. Tidying up, you end up with that. Puts a big smile on your face because that's nice. And x equals 2. Putting that back through any equation that you want, y is a 5. Therefore Q is 2, 5. Part 3, find the length of PQ. Well, we've got 2 points. The distance between them is the root of back take back squared added to front take front squared, and you end up with that. So PQ is a root 40, which is a 2 root 10. Write down the equation of the circle that has the centre P and the line L1 as a tangent. So all I've done there is regurgitated this centre point here in the formula, and this must be the radius PQ, because from P to, if you think about the circle, which I'll draw there, the tangent here at Q, I think this is going to be Q, and if that's the centre P, then the radius must be the line between them. So that's where I've got that from. And remember, x minus a squared add y minus b squared equals r squared, so we have to square with radius and write it as 40. And the last part, find the equation of the other line that is a tangent to the curve and is parallel to line L1. Yeah, this is Q here, so I've made a little mistake there in my explanation. This isn't Q, we'll call this R, like that. I just looked at the differences between these, and because they're parallel, we know that the distance from there to there is the same as there to there. Therefore, I looked at the differences between them, 6 between them, therefore it's another 6 to get to 14. Similarly, 5 to 3 to 1, just looking at the symmetry of a circle. But now I've got a point and I've got a gradient because I know it's parallel, therefore the gradient is 3. Tidying that up, you get that, which is that. So there you go, another 3 marks in the bag, just for drawing a diagram really. Question 13 then, the cost of a packet of buns in a local supermarket is X pence and the cost of a loaf of bread is X plus 75, sorry. Write an expression for the number of packets of buns that can be bought for £5.40 and an expression for the number of loaves that can be bought for £5.40. So buns equals X, loaf equals X plus 75. Therefore, for buns it's 540 over X, and for loaves it's 540 over X plus 75. Job done. The number of packets of buns that can be bought for 540 is 5 more than the number of loaves that can be bought for 540. So 540 over X, which is with buns, is equal to your loaves plus 5, because you can get 5 more buns than you can loaves, so it's loaves plus 5. So that's that. Multiplying throughout by the denominator, X plus 75, you end up with that. And then be very, very careful, expand, and you get that. This is lovely because we've got 540x on this side and 540x on this side, which just cancel away. And then we look at that, which is 5x squared plus 375x minus 40,500 equals 0. So alarm bells may be ringing at this point, but just keep the faith. Divide through by 5 here and you end up with x squared plus 75x minus 8,100 equals 0, and that puts a massive smile on your face because you see the examiner wanted you to get that. Part 3 then, solve that equation to find the cost of a packet of buns and the cost of a loaf of bread. So that horrible, ugly quadratic actually does factorize to that. You probably should have just used the formula instead of being sad like me and trying for a couple of minutes to see if it factorizes, and it does. And you end up with x equaling 60 because you can't have negative money, so it can't be 135. So your buns is 60, but remember your loaf is whatever your x is plus 75, which is coincidentally 1.35, so that's the other answer from here, but I think that is purely a coincidence. So there you go, buns 60, loaf 135, and that is the question done. 5 marks. Not too bad. Question 14 then, and I made a bit of a embarrassing mistake on this question when I first did it. Well, it wasn't a mistake, it was just I did a lot more extra work for it, but we'll go through it anyway, it's good maths. The equation of a curve is given by y equals x cubed plus ax squared plus bx plus 1. The points P and Q lie on the curve. So if we put the x and y coordinates into that equation, we can end up with 2 simultaneous equations, and we end up with that. Yeah, oh, I'm going way ahead here. Right, sorry about that. There we go. So we want the middles to match. So we've got minus 3b plus 3b. Add them together, so you get 12a equals 36. So therefore a is a 3. Put that back into an equation of your choice. B is a minus 2. Big smile on your face because you just got 4 marks for not much work. Part 2 then, find the midpoint R of the line PQ and show that R lies on the curve. So the midpoint of PQ must be minus 1, 5, just looking at the differences between x's and the differences between y's. So it's minus 1, 5. And to show that that's on the curve, you just throw the x coordinate in and hope that you get a 5 out the other end. You do, so R is on the curve. And this is the point where you should have realised, well, I should have realised, that means that you've got 3 goalposts now at the x coordinates of minus 1, minus 3 and 1. But I went ahead and tried to work out the equation of the line PQ, which I did. I'm just going to quickly put that on the screen. So there you go. that is your 3 meeting points, your 3 goalposts, which are coincidentally these 3 x coordinates. Yes, I overlooked that in the original, but I do have an excuse for that. I did start this question, then I went for my tea and came back to this question, so I totally forgot that we had the x coordinates, but that is the reason for that. Big deal. So we've ended up getting our goalposts, and now we want the area of A1. You can do it through area of a trapezia, but I didn't do that. I like the good calculus way of doing things. So we do the ceiling take the floor, and in the first case, the ceiling is the curve and the floor is the line. So to be honest, you did have to work out the equation of the line if you wanted to do it this way, so it wasn't all wasted work. So there we go, we've got that ceiling take floor, and we're going to integrate between the limits of -1 and -3, which is here -3 -1, and that is that of the ceiling take the floor. Add 1 to the power, divide by the new power, and you end up with that. That should be a -3 down there. Put your -1 through, put your -3 through, take them off each other. A1 is 4. Now then, you do exactly the same with A2. Ceiling take the floor. This time the ceiling is the line and the floor is the curve. So we'll do ceiling take floor, swaps everybody's signs over, so you end up with the integration between 1 and -1 this time, because that is 1 there. Same procedure, add 1 to the power, divide by the new power, put a 1 through, put a -1 through, and you end up with 4. Big smile on your face, because what you're meant to show is that A1 and A2 are equal, pardon me, at the end there. So that is that, and I believe that is 100% correct. I hope there's no mistakes in there, because I'm not recording it again. But yeah, don't worry too much. I think the whole country as a whole found the paper quite awful, so you know, don't worry about it too much. As for grade boundaries, I've had this question quite a lot. I personally think it'll be low to mid 60s, but I mean, that's just a prediction. It could even be mid 50s, depend on what happens, because I believe the way things work is that the same proportion of people have to get A's every year. So you know, if you're in the top 10%, you'll get an A, more than likely. So don't worry about it too much, though. It was an awful paper compared to usual, and I'm sure you'll have done great. As long as you were getting mid 60s, or 60 to 65, you're definitely getting an A or a B, I would imagine. So don't worry too much, and I don't think you have to put this on your CV or anything, so don't worry about that aspect. It literally is only to prepare you for A level, and just to extend your love of maths, hopefully. But yeah, this is going to be my final video on OCR FSMQ for the foreseeable future, and thank you guys for sticking along. All of your kind comments in the last 2 OCR videos. I don't expect this one to do quite as well, but you never know. So thank you very much, and hopefully I'll see you in the summer for some Edexcel further maths lessons of A level. But damn me, I'm not guaranteeing anything. But yeah, thank you guys so much, and I hope everything goes well in August. Let us know down in the comments how things go, and I'm sure you'll be absolutely fine. Best of luck for the future. Thanks for watching, and goodbye.